Good evening. My name is Scott Hines. I'm a data scientist, and today I'm going to be walking through the process of creating a filter, a la Instagram, Snapchat, those types of things. Specifically, this is a facial feature detection problem, and I also am going to talk a bit about its uses in day-to-day life and augmenting our reality. So first thing that we'll talk about is just the use cases. Next, I'll go through a bit of the problem that we need to solve in order to make this possible. And along with that, we'll talk about the process that we'll go about solving it. And then finally, we'll take a live look at the application that I created. So some of the use cases, there are quite a few. Today we're looking at an entertainment use case, specifically putting an overlay or a filter on top of my face that tracks my facial features. But there's also quite a few others. In marketing, there's using facial feature detection to be able to demo products ahead of time in a virtual way, to be able to try on hats or clothing ahead of time. You can use feature detection for eye tracking for when the eyes are looking at your social media marketing, those types of things, and get a lot of statistics on that stuff. And then also there's some just technological advancements that use this type of technology. We're already using it for our phones, to unlock our phones and different things like that. So the use cases are very many, and it's a really interesting technology and really interesting for our future. Um, so the problem that we're trying to solve, right? The overlaying an image onto another image is fairly simple. But when you want that overlay to be able to track to a certain object within that image, that becomes a much more complicated process. And specifically, we're looking at facial feature tracking. And so what we need to be able to do is to use a machine learning algorithm to very quickly predict landmarks, certain landmarks. In my case, I use 68 landmarks that track my jawline, mouth, nose, and eyes and eyebrows, and I'll then use those landmarks to have my overlay track my face. Um, so a quick look at the pipeline that I used to get this done. Um, I'm inputting the video using the CV2 library, and then for each frame in that video, about 30 frames per second, I'm taking that frame and converting it to grayscale using CV2. Then I'm passing each of those grayscale frames into the dlib library and using their frontal face detector to get a bounding box around my face specifically. Then I pass that into dlib's shape predictor, which I trained using transfer learning on a model that was already pre-trained, that that I found online, which was a really great resource. And that shape predictor is what they use gradient boosted trees method to predict all the landmarks on my face. So once those landmarks are predicted, I can now overlay either just the landmarks or also overlay an image using those landmarks as guidance on the overlay. Okay, so let's go ahead and take a look at that in action. Um, so this is kind of the landing page of my application. We can first look at what it looks like for the landmarks to live track my face. So they frame by frame are constantly tracking what's happening. And then we can do with that some things, something silly like throw Kermit on my face or any of the other Muppets like Miss Piggy, and it tracks me and tracks my movement throughout, and even my favorite Gonzo can follow me around, track me, and morph to my movement. So that's my application. That's my process. So with that, I am open to any questions that you have.